Hi, I'm Joanne, and I'm a PhD student in the Fluid Interfaces group at the MIT Media Lab. I'm presenting Putting Things into Context. Generative AI-enabled context personalization for vocabulary learning improves learning motivation. To excel, students need to feel motivated to learn, but many materials are presented in a one-size-fits-all manner. Given students' unique sets of interests and prior experiences, oftentimes students can lose interest in learning. Thus, the U.S. Department of Education has called for personalized learning approaches. When it comes to personalized learning, there are many aspects that can be modified, including a student's learning objectives, which instructional approaches are used, the pathway through which students take through different concepts, and also the learning materials. One way that learning materials can be personalized is by integrating students' individual interests, values, and preferences. This can be done, for instance, by allowing them to make choices, such as what their spaceship looks like in an educational game. Another option is to have students actively consider how concepts could be used in their own life situations. Alternatively, information about the student, such as their name, birth date, hobbies, etc., can be directly integrated into the learning materials themselves. This is referred to as context personalization. Traditionally, context personalization can be challenging to practically implement. Typically, crafting these materials is effortful and time-consuming, and therefore difficult to scale. Data also needs to be collected ahead of time, which leads to materials that are relatively rigid and only superficially use the information. Also, personalization tends to be fulfilled by educators or specialized software programs, and it affords little agency and interactivity for students. Given these challenges, what if we could use generative AI to create personally contextualized learning materials? If so, how would it influence learning performances and experiences? And what new opportunities might it enable? In this work, we pursued tackling these questions and investigated generative AI-enabled context personalization in the domain of vocabulary learning. Consider trying to study a new vocabulary word, say for a test like the GRE. Typically, you would look it up and you would be presented with its definition. As well, you would see a short phrase or sentence that showcases how that word could be used, and it's typically sourced from some pre-existing text. However, with generative AI, it is possible to create a custom example that reflects a person's unique interests. And it doesn't have to stop there. Prior literature suggests that people may be able to remember information better when it is presented as a story. As such, we could consider using generative AI to create stories as examples featuring users' interest. We took these ideas and developed a web application that features the three conditions. In a control condition, users clicked a button to reveal examples sourced from pre-existing text. In a generated sentence and generated story condition, users were able to input something into a text box to trigger the generation of a custom learning example. Using this web app, we conducted an online between-subject study on Prolific. To run the study, we first recruited participants and asked them to complete a pre-screening. They were asked to rate a set of 30 words, and if they were unfamiliar with at least 10 of the words, we invited them to complete or participate in the full study. The full study comprised 2 parts. In part 1, they were asked to complete a lesson using the web app, and to complete a survey as well as a vocabulary quiz. 1 week later, they were asked to return and take the same vocabulary quiz once again. In this study, we focused on the following research questions. Firstly, we wanted to understand how these different conditions could impact people's acquisition and retention of new vocabulary words. As well, we were interested in how it might shape the attitudes and emotions they have towards the learning task. Furthermore, we wanted to understand how people would approach context personalization using generative AI and how they would perceive the AI-generated learning examples. We pre-registered our study, and based off of a simulation-based power analysis, we determined that we needed at least 180 participants to achieve 80% power. We recruited higher numbers to compensate for possible dropout between parts, and for the analysis, we used regression models and ran post-hoc pairwise tests. In total, we collected 272 complete responses. Our participants had diverse occupations and education levels, and all were fluent in English as a prerequisite for the study. Most of the participants were native English speakers, and the majority of them had not taken the GRE before. With regards to the learning examples provided during the study, we noticed that the generated stories were generally the longest and had the longest engagement times. Based off of the Flesch-Kincaid measure for language complexity, generated stories were on average found to be the easiest to read, whereas the generated sentences were considered the most difficult. We wanted to understand what people used as inputs to drive context personalization. Interestingly, we noticed that the majority, roughly 3/4 of user inputs, were nouns. The rest were divided between the other word classes. Based on open survey responses, we learned that while several participants reported inputting their interests to drive the context personalization, people also input words to yield examples that were easy to understand, or to produce examples that reflected aspects of their own life experiences. However, to our surprise, the majority, in fact, reported trying to leverage word associations. This means they tried inputting words that they felt related well to the target vocabulary words they were learning. To assess learning performance, 2 quizzes were issued 1 week apart. Quizzes comprised of 20 multiple-choice questions involving fill-in-the-blank style questions as well as word definition matching questions. Overall, no differences were detected between the conditions for learning performance. However, the analysis did detect a decline in vocabulary retention between time points across all conditions. To understand the subjective learning experience with regards to the vocabulary learning activity, we also asked participants to provide ratings for 5 subscales of the intrinsic motivation inventory. Comparing the generated sentence and story conditions against a control, participants found the examples to be more interesting and enjoyable, or in other words, more intrinsically motivating to learn from. Furthermore, people felt that they had more agency or choice over their learning experience, and they also felt more competent at the vocabulary learning task. However, the 2 generated conditions did not differ greatly with respect to their overall perceived learning experience. We also wanted to gain insight into how people perceived the generated learning examples, and asked participants to rate them across 8 characteristics. Comparing again the generated study conditions against a control condition, participants generally rated the generated learning examples as being better aligned with their interests, more personally relatable, more related to their previous funds of knowledge, and also more humorous. Generated sentences were perceived to be uniquely more original or creative than the control, whereas the generated story condition was perceived to be more emotionally positive overall. From the results, we extracted a number of key takeaways. Reflecting on the characteristics of generative AI for context personalization, we found that it affords interactivity in the personalized experience, and it enables deep levels of personalization. So instead of people's interests being superficially injected into learning material, they can now be reflected throughout. Furthermore, generative AI makes it possible to create materials that can be perceived as fun, surprising, and exciting for learners. However, it sometimes produces unnatural outputs, and it can be difficult to steer it to provide a lot of structural variety across multiple outputs. Reflecting on how people approached AI-enabled context personalization, we were surprised that participants actually had many different strategies. Besides inputting topics of interest, a majority of the participants reported relying on word associations as a strategy. Additionally, we observed that users have different preferences for learning materials. For example, while some people perceived the generated stories to be funny, others found them to be childish and rather unappealing. And while we focused on allowing people to steer the central topic of the learning examples that they would receive, users were at times dissatisfied with other aspects of the examples, such as their length. Therefore, we noted that it will be important in the future to consider how multiple axes of personalization can be addressed in concert with one another. Finally, when it comes to the impact that generative AI can have on learning, our study did not detect a gain in learning performance, at least in the short term. However, we did find that people felt more intrinsically motivated to learn from the AI-generated examples. And this raises a question for future research. Perhaps learning motivation can serve as a mechanism to drive increases in learning performance over a longer time period. In conclusion, we investigated the use of generative AI to personally contextualize materials in the domain of vocabulary learning. And we found that generative AI is well suited to enabling deep levels of personalization at scale. While our study did not detect an increase in learning performance over the short term, we did find that people generally found it more intrinsically motivating to learn from the AI-generated learning examples. And overall, this work points to the need for more thorough investigation into the abilities and the limitations of generative AI to effectively support personalized learning.